Okay, hello. So in this lecture, we will start with the first scheduling algorithm, that is first come first serve. We can also say it as a FCFS algorithm. It is the easiest algorithm of the process scheduling. Now, as the name suggests, the process which comes first into the ready state will be executed first by the CPU, irrespective of the burst time or the priority, right? So from the name itself, you can say how the algorithm will work. So here we will see with the example the algorithm, that is how it is working, right? So here the processes are available into the ready queue. Consider the process P1, P2 and the P3, right? So here the burst time, what do you mean by the burst time? The burst time is a CPU time, or you can say the CPU cycle which is required for the process to execute itself, right? So here the process P1 requires the 4 CPU cycle or 4 millisecond burst time. P2 requires the 6 millisecond burst time, and the process P3 requires 2 millisecond burst time, right? Now all these processes are right now available into the ready queue, and we are assuming that each process comes into the ready queue at the 0 millisecond. So here we are not considering any arrival time, different arrival time. All are available into the ready queue at 0 millisecond. So all are ready for the execution. Now how the process that will be selected by the scheduler, right? So that is the algorithm we are using, first come first serve. So obviously from the first come first serve we will select first process, that's a P1, right? So how it will be represented, each algorithm that will be represented using the Gantt chart, right? So we will draw the Gantt chart, that is a representation of the algorithm. That's how it is working, how the processes are allocated the CPU, right? So we will start drawing the Gantt chart first, okay, for the first come first serve algorithm, right? So Gantt chart, that is always we will draw such a way, right? Now in this Gantt chart, that is we're considering it as a CPU, right? So this CPU always start with a 0 millisecond, right? So at 0 millisecond, how many processes are available into the ready queue? You can see that's a P1, P2 and P3. So out of this, using the algorithm FCFS, we will pick up first of all the process P1, and sorry it will be allocated to the CPU, right? So here the P1 that will be entered first, right? Next, how much burst time that is required by the process P1, that is a 4 millisecond. Now this is a non-preemptive algorithm, so as the P1 enters into the CPU, it completes its execution, then only it leaves the CPU, right? So here after 4 millisecond it will stop and it will exit from the CPU, right? Next, according to the algorithm, we will select the process P2, right? Now the process P2 that will enter into the CPU, and it will start execution at 4 millisecond, and it requires total 6 milliseconds. So here it completes its 6 millisecond, but we have to write down the total time onto the Gantt chart. That's a 6 plus 4, that's a 10 millisecond. Okay, fine. So here process P2 has completed its execution, 6 millisecond. Now the next process selection, that is P3, because the next one is a P3 after P2. So here it requires the 2 millisecond only. So 10 plus 2, it completes its execution, okay, with the 2 millisecond clock cycle, right? So here the Gantt chart for the FCFS algorithm, that is over. Now next one, for each and every algorithm we have to find out, right? We have to find out waiting time as well as the turnaround time. So we start finding the waiting time for the each of the process individually, then finding the average waiting time. Same way turnaround time we will find out. So we will start with the waiting time, okay. So we will find the waiting time for the process P1. Okay, here waiting time. How will you calculate? Okay, so what will be the waiting time for the process P1? That is equal to, you can see here from the Gantt chart. Look at the Gantt chart. Okay, at 0 millisecond process P1 that enters into the CPU, right, and it arrives at the 0 millisecond into the ready queue. So how much time it has to wait into the ready queue, that will be calculated as a waiting time. So here the waiting time formula is a first response time of that process minus the arrival time. Okay, so that is equal to 0 millisecond. Okay, for the waiting time for the P2, that is equal to first response that is generated at the 4 millisecond and it arrives at 0 millisecond, right? So the waiting time for the P2, that's a 4 millisecond. Okay, fine. And the waiting time for the P3, that is equal to first response is generated at the 10 millisecond and it arrives at the 0 millisecond obviously. So it is a 10 millisecond waiting time. So here the 0 millisecond, that's arrival time. So most probably if you are ignoring this 000, you can directly write down 0, 4 and 10. That is for the only first come first serve. Or you can say not only first come first serve, the number of processes that arrives at the same time 0 millisecond, right? So here all the processes are having the waiting time. You can say P1 having 0, P2 having this 4 millisecond, P3 10 milliseconds. So now the average waiting time we will calculate, that is equal to waiting time, that is equal to 0 plus 4 plus 10 divided by 3, that is equal to 14 divided by 3, right? So that is your waiting time that will calculated for the given processes, average waiting time, right? Now next one, now that is into the millisecond, whatever the answer that will come. So next one we will calculate the turnaround time. How to calculate the turnaround time, right? So we will calculate here. Okay, sorry, it's mash up. Sorry. So we will calculate the turnaround time here. Turnaround time for the P1, that is equal to waiting time plus burst time. The burst time of the P1, that is equal to 4 millisecond, right? So here it is 4. So 4 millisecond for the P1. Turnaround time for the P2, that is equal to waiting time of P2 plus its burst time, that's a 6. So it is 10 millisecond, right? Turnaround time for the P3, that is equal to waiting time of P3 10 millisecond plus 2 millisecond burst time, so it's a 12 millisecond. So average turnaround time, that will be total of this 4 plus 10 plus 12 divide by 3, okay, like this way, and here 26 divided by 3. Okay, so what are the answer that will be comes after division, that will be the, you can say, average waiting time, or sorry, turnaround time. Okay, so this is the way we can calculate the waiting time as well as the turnaround time. So this is the first example we have completed and it is the easiest one. Next one we will continue with see the another example, but that's not the that much easy. Okay, so next one, see this example for the first come. Now remember the algorithm, first come first serve. The process which comes first, that will enter first into the CPU. And how we will represent this algorithm? Using the Gantt chart. So again we will draw the Gantt chart. Okay, so here three processes are there. So we will draw the Gantt chart with the 3 processes here. Okay, fine. Sorry, it's overlapping. Okay. So 3 processes. Okay, fine. Now the process at 0 millisecond. Here your Gantt chart always start with the 0 millisecond. Now see into the ready queue how many processes are available into the ready queue at 0 millisecond. So here the arrival time is given. So you must consider this arrival time. At a 0 millisecond only one process. No other process P2 and P3 are there. They are not available. They are coming at 1 millisecond. So we have to see only this portion. That's a P1 0 millisecond and burst time required 7 milliseconds. So first of all, compulsory we will enter the process P1, right? Okay, so that's a process P1 and to the CPU first at 0 millisecond. So I cannot draw properly. That's a P1. Okay, so it completely requires the 7 millisecond. Okay, now this 7 millisecond is over of CPU, and within that 7 millisecond the process P2 and P3 already arrived into the ready queue. So this is a 1 millisecond, 0 and 1 already they arrived, right? So now out of these two processes we have to select one of the process. So which we will select first? That is a first come first serve. So we will select the P2, right? So here the P2 we will select next process. Now how many bursts required for the P2? That's a 5 milliseconds. So 7 plus 5 here it is 12, right? Now last one process remaining, that's a P3. Okay, fine. So P3 requires 8 millisecond burst time. So 12 plus 8, that's a 20. So this way we will draw the Gantt chart. So now the Gantt chart is over. From the Gantt chart itself we will find out the waiting time, right? So the waiting time for the individual process. So here the waiting time for the process P1, that is equal to the process P1 first response at the 0 millisecond and it arrives at the 0 millisecond. So here the 0 millisecond, it's waiting time. Process P2 waiting time, the first response is generated 7 millisecond. Here you can see that's the first response. It is generated 7 millisecond and it arrives at the 1 millisecond. See here the difference, you can say the calculation waiting time. So it's a 6 millisecond. And the P3, that is equal to first response is generated at the 12 millisecond. On the Gantt chart you can see, and it arrives at the 1 millisecond. Here you can say 1 millisecond it comes, right? So that's why we are writing this arrival time. So here 11 millisecond waiting time, right? Now the same way you can calculate the turnaround time for each of the process, right? So for the process P1 turnaround time, that's the waiting time. Okay, what is the equation? Waiting time plus burst time, right? So here P1 waiting time 0 millisecond plus the burst time that requires 7 milliseconds, so it's a 7. P2 waiting time, it is a 6 millisecond, you can see here, right? And the burst time, that is for the P2, that's a 5. So it is a 11 millisecond, right? P3, that is waiting time 11 plus 8 burst time, so it is a 90 millisecond. So find out the average waiting time, equal to 0 plus 6 plus 11 divided by 3, that is equal to 17 divided by 3. You can say 3, 5. 6 millisecond. Okay. An average turnaround time, here it is turnaround time of P1 plus P2 plus P3 divide by 3, that is equal to 37 by 3, that is equal to 12.33 millisecond. So that's all. Our main purpose is performing the scheduling algorithm. We have performed the FCFS and then calculating the average waiting time as well as the average turnaround time. Okay, so with this first come first serve algorithm, that is over. We will see the next algorithm, that is into the next lecture. Thank you.